Dear students, now let me discuss another problem on special theory of relativity which is asked in JAM 2007. Okay, and the question is here: a particle travels along the diameter of the earth at a relativistic speed. It crosses the earth in a time 3 into 10 to the power minus 2 second in its own frame. So this statement is very useful. It crosses the earth in a time. Okay, the particle is travel along the diameter of the earth like this. Okay, suppose there is a path along the diameter. So the particle is moving along this direction, along this path. Okay, along this diameter. And it crosses the earth in a time 3 into 10 to the minus 2 second. But this time is measured in its own frame. So it is proper time. So you can write over here the proper time. Proper time is given here. Okay. So proper time is delta T naught is equal to 3 into 10 to the power minus 2 second. Now an observer located on the earth. Okay, here is an observer. Let me suppose here is an observer. Okay. So an observer located on the earth measures the same interval to be 5 into 10 to the power minus 2 second. So now this time interval is measured from another frame. So this is the dilated time, you can say. Okay. So it can be written as dilated time, which is delta T, and that is 5 into 10 to the power minus 2 second. Now we have to find out the speed of the particle with respect to the earth. So we have to find out the speed of the particle with respect to the earth. Let me suppose the speed of the particle okay, with respect to earth is equal to v. With respect to earth is equal to v. What it means? It means that the velocity of the frame attached to the particle is v. Suppose this is a frame S which is attached to the observer, and the particle, this is the frame S dash which is attached to the particle, and this S dash is moving with velocity v. So the particle is moving with velocity v. It means that the frame attached to the particle that I have assumed here is dash is moving with velocity v. So the velocity of S dash frame with respect to S is v. And in this kind of situation, we have the relation between delta T and delta T naught, which is given by delta T naught is equal to delta T divided by root 1 minus v square by c square. Okay, so this is actually delta T is equal to, because delta T is equal to delta T naught upon root 1 minus v square by c square in this situation. So we have to relate all times our formula in actual case and in given problem. In actual case, when I have discussed these formulas, in actual case we have a frame S and another inertial frame S dash which is moving with respect to S in velocity v, and in this situation the time interval measured in S dash frame is delta T and the time interval measured from S frame is delta T, and these two time interval are related by this equation. And here this delta T is always greater than delta T naught, because here root over 1 minus v square by c square is less than 1. So this is the dilated time and this is the proper time. Now here S frame means earth. Here S frame means earth and S dash frame means particle, and the particle is moving with velocity v, with speed v, relativistic speed v I have taken here, and this velocity we have to find out. So let me put the values of delta T and delta T naught here from this given information, and we will get easily v from this equation. Okay, you have to understand actually which things are given and which we have to determine, and at the same time we have to choose correctly the S and S dash frame which should match for our theory. Okay, in theory part, when I am applying this formulas, I have assumed something in theory, and from there I have written this formula. So when I will use this formula, I have to always match the notation and the quantities on the original one, and only in that case your answer will be correct. Okay, so delta t is equal to delta naught root over 1 minus v square by c square, and here delta t is 5 into 10 to the power minus 2 second, and delta t naught is 3 into 10 to the power minus 2 second divided by root 1 minus v square upon c square, which implies that root 1 minus v square upon c square is equal to 3 by 5, because this 10 to the minus 2 and minus 2 will cancel out, so it will be 3 by 5. So 1 minus v square upon c square is equal to 9 by 25. So v square upon c square is equal to 1 minus 9 by 25, that is 16 by 25. So v by c will equal to 4 by 5. So v will be 4c by 5. Okay, so this will be your answer, 4c by 5. V will be 4c by 5. Okay, so this is the speed of the particle with respect to earth, which is actually the speed of frame s dash with respect to s. Now we have to find out the diameter of the earth, and here the diameter of the earth should be with respect to earth, so it should be with respect to s frame. So for s frame we have to measure the diameter. Of course, for s frame, for particle frame it will be different, the length will be contracted. In particle frame the length will be actual length, the length will be proper length, but we have to find out the diameter of the earth with respect to earth, of course. So in that case we have to use the time interval measured from earth, and time interval measured from earth is delta t is equal to 5 into 10 to the power minus 2 second. This is the time interval measured from the earth, that is from the s frame. So the diameter will be nothing but, this is actually the distance r, which is nothing but v into delta t, and v we have measured the velocity of the particle with respect to earth is 4c by 5. So it will be 4c by 5 into delta t, that is nothing but 5 into 10 to the power minus 2. So this 5 will cancel out, and it will be 4 into 3 into 10 to the power 8 meter per second, that is the speed of light in free space, into 10 to the power minus 2. So it will be 12 into 10 to the power 6 meter. Okay, so it will be the diameter. No, this will be the diameter, and the radius will be, we know the radius will be r by 2. Okay, so it will be 6,000 kilometer around. We know this result actually, but this is the result we can approach from this kind of problems. Okay, so we have to always very careful about the fact that velocity of s dash frame with respect to s, and another is time interval, for which frame the time interval is given, for which frame the length is given, and for which frame the length we have to calculate. Okay, so many things this you have to very careful when you solve the problems. Okay, thank you.